Good evening everyone. Welcome to one problem per day or one concept per day problem portal. And today we are doing problems on electricity or electric circuits. Okay. So this question is taken from May 2002 paper HL section. Okay. Now let us start with this. So the first question is about testing an electrical circuit. So this question is a very interesting problem which relates something like what happens when the resistors are being shorted or open circuited and so on, which gives you all the fundamental ideas about how do you start analyzing a circuit. Okay, the diagram below shows an electrical circuit consisting of four identical resistors RA, RB, RC and RD. There's a voltmeter connected here. 6-volt supply is being connected over here, which means what you can connect a battery here. You can connect a battery here. Okay, that's what it tells you. Okay, commercial resistors sometimes fail in one or two ways. They can go open circuit, in which the resistance of the resistor becomes infinite. Make it big, larger. Okay, and or they can go short circuit, in which the resistance becomes zero. Which means what? If you say it's an open circuit, then you can say R is equal to infinity. When you say short circuit, R is equal to zero. I will write it down. This is your open circuit. This is your closed circuit. Okay. In order to test the circuit, a technician connects a high resistance voltmeter between the terminals X and Y and applies a potential difference of 6 volt across the resistor A. So, in order to test this, he puts a 6 volt resistor and puts a voltmeter on the other edge. Right. Now, what voltage will the voltmeter read if all the resistance are functioning normally? If every resistance is working properly, then what will be the voltmeter reading? What will happen? So towards it, what will happen is that when you have 6 volt here, when you have 6 volt over here, now see all these resistance are equal. Okay, so as a result of it, this 6 volt will get dropped here, will get dropped here. Okay, and the dropping of these voltages would be the same, which means every resistor will have 2 volt here, 2 volt here, and 2 volt here. Why am I not including this one here? The reason is because you see this battery is connected in parallel to this one. So whatever is the voltage drop here, this will definitely be equal to 6 volt only. Okay, this will be 6 volt, but don't say considering that this is 6 volt and this is 6 volt, so I can add them together and say 12 volt. Some of them do this, or you can also say some of them do something like this is 6 volt and this 6 volt. They are parallel, and as a result of it, I can have this as 3 volt. No, both the things are wrong. Okay, so therefore, the analysis is something like this. You can use the addition or something like 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, reciprocal addition, only when you have resistances over there. Okay, you're not supposed to do it for the voltages. Okay, so therefore we are not going to do both the things. We're just going to say the voltage across this terminal is equal to 6 volt. The voltage across this whole terminal, this entire voltage is getting dropped over here as 2 volt, 2 volt, and 2 volt. So what's the reading on voltmeter? 2 volt. Okay, now let us write down that. So what will be the voltmeter reading? It will be 2 volt only. What would the voltmeter read if either resistor RB or RD were to be short circuit? Which means what? What do you mean by short circuit? Short circuit means R equal to 0. So what is he asking here? If suppose if RB is equal to 0, okay, so let me write it down here. If RB is equal to 0, then what will be the voltmeter reading here? 0 here. Okay, now the entire 6 volt is going to get divided amongst these two. Okay, I'm going to make only one resistor to be 0. Either RB equal to 0 or RT equal to 0. So if RB equal to 0, then voltage across this would be 3 volt. Voltage across this would be 3 volt because 6 volt is divided by 2. So therefore, your VC will be equal to 3 volt. The same thing applies even if I put RD is equal to 0. In both the conditions, you see VC will be equal to 3 volt. Right? Now let us write down that. So this will be equal to 3 volt. If the electrician were to note a reading on the voltmeter that suggested either RB or RD has short circuited, how would he test at which one of these had in fact short circuited using only the voltmeter? Now the question is, there is an electrician who comes to a circuit and then what he does is he wants to test which of these were seen to be short circuited. What is that he will do? He will take a voltmeter, connect it across these terminals. When he connects it across these two terminals, and he finds this is equal to 0, the voltage across this is equal to 0, immediately he can say that this resistor seems to be short circuited. Okay, but if it is not, if it is showing some value, 3 volt is showing over here. Okay, and Here he connects it across and he finds out that the voltage here is equal to 0. Then immediately you can say this voltage is equal to short circuited. So like this, okay, wherever the short circuit happens, which means the voltage drop across that resistor is equal to 0. Okay, so therefore, how do we write? So these are all 1 mark, 2 mark, and so on. Now this is for 2 mark. So what do you write? Need to write? The first mark would be voltmeter. Voltmeter has to be connected in parallel to each resistor. Each resistor is the first thing. Secondly, if voltmeter reading is equal to 0, that resistor is short circuited. This is what you can infer. Okay, now let us go on to the next one. Identify two possible faults with the circuit that will produce a reading of 6 volt on the voltmeter when it is connected between X and Y. Identify two possible faults. Where do you identify the fault over here? Where are the faults which can be seen? Where the voltmeter can read 6 volt. Okay, now it is not reading 3 volt, it is reading 6 volt. When can it happen? When this is also short circuited, this is also short circuited, then what will happen? The entire 6 voltage also that's being given over here will also appear over here. Okay, so therefore now you can say that if RB is equal to RD is equal to 0, which means what? These are 2 marks. So it implies what? If RB and RD are, here I put R and over here. In the previous one, it was R over here. R short circuited, then VC will read 6 volt. Okay, now let us move on to the next one.